This is a very good example to see how the Coulombs law can predict what the velocity of an orbiting electron in the hydrogen atom is. This orbiting electron in the hydrogen atom is the only electron. The hydrogen atom only has one electron and one proton. So then the whole nucleus of the hydrogen atom is actually just the proton, and the electron is going just around it in a very, very high speed. Okay, so if the radius of the at which this electron is orbiting is equal to 5.29 times 10 to minus 11 meters. As you can see, it's very small. Okay, we know that this is the electron, and the charge of the electron is equal to 1.6 times 10 to minus 19 coulomb. Okay, we are also required to know some of the other information, like the mass of the proton itself. So the mass of the proton, that would be also given, and it's equal to 9.1 times 10 to minus 31 kilogram. Look how small that guy is. So the electron, as you can see, is going in a perfectly circular motion around the proton. If that happens, then we know that the electron should be under the influence of two forces that are at equilibrium. One is trying to push him away, okay, and the other one is trying to attract him into the because the electron is negative, and this is the proton is positive. The proton will trying to attract it, so it's gonna swirl into the proton, but the electron does not do that, and the reason is because there's an outward force that is pushing it away. This force is the centrifugal force. The centrifugal force is equal to the centripetal force that usually points toward the center. That's the centripetal force, but the centrifugal force is the opposite to that, so I'm going to call it C centrifugal, maybe CF. Okay, and the centrifugal force is equal to the centripetal force always. Okay, this CF is equal to the mass times V squared over R. So this force you learned in an earlier probably class in the first algebra physics class. Okay, so mv squared over r. M is the mass, v is the velocity, r is the distance between or the radius of a circular motion, basically. Okay, so if this centrifugal force is equal to the Coulomb force, F sub c, that's C for here, Coulomb. Okay, all right, and F sub c is equal to 9 times 10 to the power 9 Q1 times Q2 divided by the distance squared. Okay, so these two forces should be equal, and that's how we solve this problem. So I'm gonna take that here and put it here. So I'm gonna say mass, and this is the mass that causes the center, which is mass of the proton, okay, times v squared divided by r is equal to 9 times 10 to the power 9 Q1 is, let's say, the charge of the electron, Q2 is the charge of the proton, but they are both the same. Q1, Q2, let's just say it's Q squared now, because the charge of the electron and the charge of the proton is the same, divided by the radius squared. Now this square goes with this, okay. Q is known, the mass of the proton is also known, R is given. The only thing that is known is that is unknown is the velocity square. Okay, so let's just plug in the numbers. So MP is equal to 9.1 times 10 to minus 31 times the velocity square is equal to 9 times 10 to the power 9 times q square, which is 1.6 times 10 to minus 19 Coulomb square, and divided by the radius, which is 5.29 times 10 to minus 11. Doing some calculations, you can find out that the velocity of the electron is equal to 2.19 times 10 to the power 6 meters per second. Can you imagine how fast that guy is going around the nucleus? It's about 2 million meters a second. But I bet this guy can go around the Earth in less than a second. That's what I can tell you. Okay? And that's it. Thank you very much.